Welcome to Didactic Residency Edition. Today is Wednesday, May 3rd, 2023, and I am Dr. O'Leary. I'm nearing the end of my third year of psychiatry residency in the National Capital Region. I do this podcast because I love it. I love learning about psychiatry, I love learning about neuroscience, and I love communicating it to other people. I want to let you know, though, that everything that I say here is really just my own opinion. It doesn't represent the opinion of the federal government, the Department of Defense, the Defense Health Agency, or even the National Baseball League. Everything I say here is my opinion, so take it for what it's worth. I want to start by telling you a story. A while ago, a patient came into my office and reported to me that one of the symptoms he noticed after discontinuing his escitalopram was an increase in impulsive behaviors. When I asked him to explain what he meant by an increase in impulsive behaviors, he reported that he does things that, quote, bring me excess amounts of pleasure, unquote. I was intrigued, thinking he might tell me something that would raise my suspicion for a bipolar type disorder. What kinds of things? I asked. He replied, "Oh, I masturbate and look at pornography." Does he do this excessively, like many times a day? No. Does he frequently seek out new sexual partners? No. After pressing him for something that might make me concerned for some sort of pathological impulsivity, he reported to me that he believes when he masturbates, this results in a huge load of dopamine being released into his brain, so much so that for the next day or two, he can't feel much other kinds of pleasure, like watching movies and stuff. It was then that I asked him, "Have you ever read about Dopamine Detox?" Today, I want to talk about dopamine. I've mentioned monoamines before, like dopamine, serotonin, norepinephrine. I mean, they're psychoactive players in many of the drugs that psychiatrists give patients. Dopamine is unique among them for having taken on an almost mythical status in our culture as a bringer of pleasure and doom. Dopamine could be loosely compared with Harvey Dent in Batman, that good and benevolent district attorney turned Gotham supervillain. The pleasure he once received by doing good for his community is replaced by a desire for mischief, chaos, and revenge. There's a similar narrative wave in popular psychology and neuroscience that's taken a small amount of very basic science and twisted it into a fantastic narrative of feast and famine. Its central character is dopamine. The dopamine detox, also known as dopamine fasting, is a pseudoscientific treatment that best illustrates how magnificently strange and evidenceless some claims about dopamine can be. One of my fears is that psychiatrists and psychotherapists will use pseudoscience like this to inspire patients to either believe in bogus treatments or to assign disturbing amounts of significance to benign actions. Take that example of masturbation. If you were taught by your therapist to believe that masturbating at night after work is going to result in a large amount of dopamine being dumped, and that will delete your ability to feel pleasure for the next, say, 2 days, then your therapist is causing unnecessary distress by spreading fake science. First, do no harm. If your patient's masturbating in the bathroom at work on their lunch break, this should be addressed. But if they do it a couple times a week in the privacy of their own home, this is healthy and normal and no cause for shame. I mean, even if they do it every night to relax. Your patient doesn't need the burden of blaming last night's masturbatory session on their current day's malaise. If they do, then that is something to explore. There is a purportedly science-based idea that engaging in pleasurable activities will somehow either deplete your brain of dopamine or raise the bar in order for your brain to be able to consider things pleasurable. And this will result in the need to do pleasurable things more often or for longer periods of time or with more intensity than you did it before in order to receive the same level of satisfaction. This pseudoscientific idea is often explained by comparing pleasurable acts to addictive substances or impulsive behaviors. The idea is that if there are people who use substances like methamphetamine or do things like play video games incessantly or scroll through TikTok to get pleasure, and abstinence from these substances or acts causes a kind of dysphoria. This means that they have either depleted the dopamine stores in their brain or increased their tolerance to dopamine. And then the solution is a dopamine fast or a dopamine detox so that you can get back to your natural levels of dopamine. Let me read you something I encountered from an article called How to Do a Dopamine Detox. And this is from the website gamequitters.com. Quote, instead of getting enough dopamine from everyday activities, individuals suffering from addiction rely on receiving dopamine from drugs, alcohol, video games, or other external stimuli instead. Unquote. They go on to claim, quote, the side effects of too much dopamine include ADHD, addictions, binge eating, and other binging behaviors, gambling, obesity, unquote. I really have no idea how ADHD got into that mix, being a neurodevelopmental disorder and not something that you develop by doing drugs or playing video games. I imagine that they're mistaking the appearance of ADHD that might arise when someone has poor organizational skills because they've never learned how to exist in a structured work environment with the actual disorder of ADHD. The idea that we should take a break from things that have taken undue control over our lives is not new, and when done intentionally can be an effective way to combat certain addictions or impulsive behaviors or compulsive behaviors. But to convince someone that dopamine needs to be precisely conserved lest you become a joyless zombie is completely out of touch with the science of dopamine. Had GameQuitters.com been the authoritative source on dopamine in our lives, I probably would not have even bothered to do an episode about this. But then I listened to multiple podcasts, both featuring Stanford faculty, one a psychiatrist and the other a neuroscientist. I've included links at the end of the show's transcript at psydactic.buzzsprout.com. It may not surprise you that these Stanford experts are either selling books or a plethora of supplements in order to support the good work of spreading their message to the masses. I will avoid giving names in this episode because I don't sell supplements or books or anything really to anyone, so I don't really have the monetary resources to engage in a prolonged legal battle if someone decides to try to silence me by filing a predatory lawsuit. I'm also not suggesting that they would, just that I'm not in the position to test that hypothesis. What I'm going to say doesn't depend on the identity or even the credentials of the individual that I'm talking about. I'm trying to promote healthy skepticism of what people claim is, quote, science-based information, unquote. I think I have a more rigid definition of science than most other people. I should also say that I was impressed with the amount of actual scientific information that people promoting their dopamine narratives include. However, many of the popularizers of dopamine fasts or dopamine detoxes do not present their opinions as mere hypotheses, but as well-known facts or science-based facts. They do include many facts. Many facts. In some ways, listening to them was a good review for me, and I probably learned something, though I'm not sure I can trust what I learned. For example, one of the hosts reported that we can increase our available dopamine by sitting in a cold water tank up to our neck for as long as an hour. He said that this was confirmed by peripheral blood draws showing that dopamine levels went way up. On the surface, this sounds impressive, but in actuality, dopamine doesn't readily cross the blood-brain barrier. I mean, that's why when we give dopamine to Parkinson's patients, it's in the form of levodopa, which can cross the blood-brain barrier and then be converted into dopamine. And we give this along with carbidopa, which does not cross the blood-brain barrier, to prevent peripheral tissues from converting the levodopa into dopamine outside of the brain, because this can result in a lot of unwanted side effects. A peripheral blood draw doesn't tell us much about what dopamine levels are in the brain, and it doesn't tell us what else is going on that we did not measure. Even if we do a spinal tap, we still wouldn't know where in the brain dopamine was most available and active. What separates pseudoscience and the fringes of evidence-based medicine from actual science and science-based medicine is the extent that the purveyor makes unsupported claims based on either preliminary or very basic scientific findings. Often this basic science is included in a shotgun fashion, is quoting fact after fact in an attempt to kind of overwhelm the listener with so much information that they're left with no choice but to think, this speaker must be onto something. Searching for facts that appear to be consistent with a preconceived notion is called cherry picking. And just because your bucket's full of cherries, it doesn't mean that there's actual evidence for the claim being proposed. In fact, the opposite is true. A bucket full of cherries is most likely to result in a rotten mess. Each of those facts independently has a level of uncertainty associated with it, and adding more uncertain facts does not add to certainty. It multiplies uncertainty. Basic science answers very specific questions, and it hints at other possible areas of research. Science is painfully slow, but when it progresses, it produces durable results. Pseudoscience takes very specific answers and builds a giant web of illusory knowledge around it. The links between each of the nodes is weak, and when tugged at, the whole web comes tumbling down. Pseudoscience is fast, and it produces misleading results that have unpredictable consequences. The telltale sign of an illusory web of facts is when a speaker is willing to sell you food products and supplements that, for example, quote, boost dopamine naturally, unquote, instead of the unnatural way that you're supposedly doing it now. A name that I will now mention is Dr. Cameron Sepah, S-E-P-A-H. He's a Harvard graduate who is listed as the CEO of Maximus and executive psychologist and professor at UC San Francisco Medical School. He popularized his own ideas about dopamine fasting that he termed Dopamine Fasting 2.0. He goes to lengths to try to clarify that his method is not aimed at actually reducing dopamine, but instead at regulating impulsive behaviors. The fact that he called it a dopamine fast instead of an impulse fast doesn't help to reduce anyone's confusion. He also wants to make it clear that his method does not discourage people from engaging in other activities that can increase their dopamine if these are healthy, like exercise and hanging out with your friends. He has to make these clarifications because he did not invent a dopamine fast. It was a trend for many years before he invented it as 2.0. And many people who do it or did it and still do it will limit all pleasurable activities like eating tasty foods or talking with their friends in an attempt to reset dopamine levels in their brain. Dr. Seppa instead focuses on addictive, impulsive, and compulsive behaviors and proposes a plethora of cognitive behavioral therapy-based interventions such as stimulus control, exposure and response prevention therapy, and mindfulness-like methods. However, these therapies were not developed for the indications that he's proposing. I mean, that's not a problem in itself. We often use therapies kind of off-label because they seem to apply, and sometimes that's good. What makes his method something that he can actually claim some original credit for is that he prescribes a schedule to abstain from unwanted behaviors that people should use to gain more control over their lives. This includes a dopamine fasting schedule of 1 to 4 hours at the end of the day, of course, depending on work and family demands. 1 weekend day, spending it, for example, like outside, either on Saturday or Sunday, or one weekend per quarter to go on a local trip somewhere. And don't forget 1 week per year, just go on a vacation. If you don't find this prescription groundbreaking, then you're not alone. I mean, what confounds me is why Dr. Seppa seemed to have thought that co-opting a pseudoscientific trend could result in anything other than more pseudoscience is beyond me. It certainly gave him and his company a lot of attention. Maximus, the company that he's part of, sells pharmaceuticals such as enclomiphene, which is a selective estrogen receptor modulator that reportedly increases testosterone levels by increasing release of gonadotropin in the pituitary. Tadalafil, as known to treat erectile dysfunction. I've prescribed it to people myself. Bremelanotide. It was approved as a subcutaneous injectable for reduced libido in women, but it's sold by Maximus in pill form for men. Interestingly, like the Mayo Clinic website states that men should not use bremelanotide, but to be fair, like off-label use of medicines is common in practice. I've used off-label medicines many times. In addition, Maximus will sell you a concoction to help men regrow hair. This concoction does contain pharmaceuticals that have an indication for hair regrowth. I should also report now that I'm not an expert in male sexual performance, and this podcast is not specifically about male sexual health or hair growth. I am confident, though, to report that some patients' ideas as to what a dopamine fast or a dopamine detox is can result in sexual shaming and maladaptive behaviors, which is not helpful. Now I'm going to spend an inadequate amount of time discussing some of the basic science of dopamine. Dopamine is a neuromodulator that's generally excitatory to neurons after it's released, which means that when it is released into synapses, it hits G protein-coupled receptors on the postsynaptic neurons, and this ultimately results in a greater potential for signal induction in those neurons. It basically makes them more excitable. But just because a neuron is excitable doesn't mean that when it fires, this will result in a downstream excitatory effect. That neuron stimulating another neuron could actually result in inhibition of something. In psychiatry and neurology, dopamine is probably best known for its role in movement disorders and in reward-based reinforcement learning and memory. It's also proposed to play a central role in disorders like bipolar, with mania, and in psychosis. Dopamine is produced in the substantia nigra and then exported through nigrostriatal pathways to the striatum. The striatum is involved in executing movements that are first planned in our premotor cortex and then initiated in our motor cortex before being coordinated with the rest of our body in the striatum. We know that death of neurons in the substantia nigra results in a relative decrease in available dopamine, which results in difficulty suppressing and initiating movements in the striatum. Without sufficient dopamine, parts of our bodies move when we don't want them to, and other parts are hard to move even if we try. Parkinson's disease and dementia with Lewy bodies both often manifest in tremors or rigidity, and they're both associated with death of neurons in the substantia nigra. Dopamine is also produced in the ventral tegmental area and then transmitted via the mesocortical pathway to the prefrontal cortex and the mesolimbic pathways to the nucleus accumbens and the olfactory tubercle. These pathways are connected to our higher reasoning and to our more basic emotion and memory processing centers, and they're thought to play key roles in things like addiction or mania and psychosis. Dopamine is also produced in the hypothalamus of the brain, and it aids in memory formation and in retrieval, which is thought to help reinforce novel, rewarding, and addictive behaviors by emphasizing reward-based memories. However, we know that serotonin, norepinephrine, and glutamate can also affect these functions and affect them profoundly. When it comes to treating addictions, I asked, like the psychiatry residents in the audience right now, how many direct dopamine modulating agents do we have that have good evidence for treating addictions? I'll give you a moment to ponder that question. One agent we have is bupropion, or Wellbutrin, and it's a dopamine and norepinephrine reuptake inhibitor that has been shown to help some people with smoking cessation, or at least to smoke less. But I'm at a loss to find others off the top of my head. While most of our addictive drugs have a pathway that is thought at some point to lead to dopamine dysregulation, they also do many other things. Opioids, nicotine, alcohol, which are some of the most profoundly addictive substances we know, have effects on far more neuromodulators than just dopamine. Drugs like cocaine and methamphetamines have more direct effects on dopamine, but they represent a small number of our addicted patients. Maybe dopamine is not the end-all, be-all of addiction that simplistic reasoning would have us postulate. It certainly plays a role, but it also is certainly not the only master of addiction. Psychosis or mania has been thought to be caused by excessive amounts of dopamine, but we also know that psychedelic substances can cause hallucinations and delusions, like LSD, which acts as a serotonin agonist. Glutamate receptor agonists like ketamine can also cause delusions and dissociative or psychotic-like experiences. We know that excessive amounts of amphetamines, which do increase dopamine, can cause psychosis, but this normally takes a lot of them, and often the psychosis is associated with a long period of time without much food or water or sleep, along with the use of the substance. To lay the burden of psychosis solely on dopamine ignores the fact that many second-generation antipsychotics and serotonin modulators like pimavanserin can treat many forms of psychosis. Blocking dopamine receptors may work sometimes, but not always, and comes with a load of side effects, including severe movement disorders like tardive dyskinesia when we give these substances over a long period of time. None of the hypotheses stating that we can fully explain addiction or impulsivity or psychosis or compulsive and impulsive behaviors primarily by too much or too little dopamine or getting spurts of dopamine at the wrong time makes any sense when you look past the surface. There are some isolated examples where pathologies obviously affect dopamine levels, like in Parkinson's and Lewy body dementia, and we see the consequences in the brain, but our brain, under anything approaching normal operating conditions, is far too complex to be so easily explained. Let me ask you this now. If a neuroscientist who spends their life engaging in social media, such as their podcasts, their website, their Facebook, their Twitter, their TikTok, or whatever other media, is asking you to buy their sponsored natural substance that's supposed to increase or better regulate dopamine levels in your brain so that you can enjoy life without the need for what they're characterizing as unnatural or impulsive ways of doing this, is this not at some level hypocritical? Whether it is hypocritical or not, it is certainly not science. It is a mythology built within a scientific landscape. They build trees out of science and houses out of science, but then they flow through it in a way that has nothing to do with science. It is certainly a good way to get sponsorships and sell books or supplements. If you don't remember anything else from this episode, at least remember that Dr. O'Leary begged you to please stop telling patients to detox from dopamine or take dopamine fasts. In my humble opinion, you are not just confusing everyone, but possibly causing them harm. I am Dr. O, and this has been an episode of Psydactic Residency Edition.